In this lesson, you will learn how to find the perimeter and area of polygons in the coordinate plane. Recall that the perimeter of a polygon is the distance around the figure. So if you take this triangle here, which is a three-sided polygon, you take the distances around the outside, which would be 5 plus 8, and you get that the triangle has a perimeter of 18 centimeters. You can use the distance formula to help you find perimeters of polygons in a coordinate plane, if you use the distance formula. If you have two arbitrary points, x1, y1 and x2, y2, you can find the distance between them using this formula. Basically what it says is you take the difference between the x-coordinates, square it, you add to that the difference in the y-coordinates, square that, and you take the square root of the entire result. For example, suppose you have the points A with coordinates -3, 4 and B with coordinates -1, 4. In order to find the distance, you take the difference in the x-coordinates, or the distance between the x-coordinates, so I have -3 and -1 here. Notice altogether they're 2 units apart. Okay, so I get -2 here, and I square that, and I get 4. The other part of the expression I take by getting the distance between the y-coordinate of point A and the y-coordinate of point B. So altogether they're 8 units apart. Square that, I get 64. Add what's in the radicand, 4 plus 64 is 68. Take the square root of that result, and the simplified version of that is 2 times the square root of 17. In this example, we'll find the perimeter of the pentagon with the following vertices, and we'll round to the nearest tenth. Since AB is a vertical line segment, I can find the distance between A and B just by counting the units between them. Notice there are 1, 2, 3, 4 units between them, so the distance AB is given by 4 units. Now for the other line segments, notice that they're not vertical or horizontal, so I need to use the distance formula in order to find the lengths AE, ED, DC, and CB. When I'm finished finding those distances, I'm going to add all of these distances up to get the perimeter of my pentagon. Alright, so first we'll find the distance BC. Take the difference in the x-coordinates between B and C, notice that's 1, 2, 3, 4 units. Square that and I get 16. The difference in the y-coordinates between B and C is exactly 1 unit, and I square that and I get +1. So my resulting expression for the length BC is the square root of 17. Notice that I don't need to calculate the distance CD because CD is a reflection of BC across the y-axis. So these two line segments are congruent, therefore they'll have the exact same length of square root of 17. Next we'll find the length of line segment DE. Notice that it's not a horizontal or vertical line segment, so I need to use the distance formula once again. To use the distance formula, I find the difference in the x-coordinates between D and E. Notice that that's 1, 2 units. Squaring 2 units, I get 4. The difference in the y-coordinates is 1, 2, 3, 4, 5 units. Squaring 5, I get 25. Adding those two together in my radicand, I get square root of 29 as the distance DE. Do the exact same thing with the last line segment, EA. The difference in the x-coordinates is 2 plus 4, so that's 6. Squaring 6, I get 36. Plus the square of the difference in the y-coordinates of A and E, so that's 1 unit. So I get the square root of 36 plus 1 is the square root of 37. Now that I have all the lengths of the individual line segments, I add them together to get the perimeter. So adding these segments together, I get this expression. And then I just use a calculator to evaluate this expression and round to the nearest tenth. So I get that the perimeter of pentagon ABCDE is approximately 23.7 units. Remember to come to class with these reflection questions answered so that we can discuss them. Okay, the density of an object is its mass per unit volume. For example, the density of gold is 19.3 grams per centimeter cubed. This means that each cubic centimeter of gold has a mass of 19.3 grams. You can also define density in other situations that involve area or volume. For example, the population density of a region is the population per unit area. So what we're going to do in this example is we're going to approximate the population density of Vermont. So they're giving us that the Vermont has a population of 621,760 people, and its border can be modeled by a trapezoid with these points as the vertices. Each unit of the coordinate plane represents 1 mile, and we're going to find the approximate population density of Vermont. So what I do first is I plot my trapezoid, which models the state of Vermont, on the coordinate axis here, and connect the dots using a straight edge. Now, in order to find the area of this trapezoid, I divide it up into 2 polygons that are easier to find the area of. In particular, I would divide it up into a rectangle and a triangle by drawing the perpendicular line segment from D to BC. Then I find the area of this rectangle, the area of this triangle, add those 2 up, and that'll give me the area of the trapezoid. So if you remember, the area of any rectangle is its length times its width. Notice that the length of this rectangle is 160 units. Remember, each one of these lines represent 20 units. The width of it is 40 units. So the area of this rectangle is 160 times 40, which is 6,400 units squared. The area of this triangle, or any triangle, is 1/2 times the base, the length of the base of the triangle times the length of the height. Well, notice that the length of the base here is 40 units. The length of the height of this triangle is 160 units, just because it's one side of the rectangle. We already knew that this side of the rectangle is 160 units. So multiplying this together, I get 3,200 units squared. So then I know the area of the trapezoid just by adding up the area of the triangle plus the area of the rectangle, and I get 9,600 miles squared. So in order to find the population density, I need to take the total population of Vermont and divide that by its area, because remember, that's the definition of density. So the population was given to us as 621,760 people divided by the total area, 9,600 miles squared. That gives us a population density of 64.77. And if we're rounding to the nearest tenth, that's going to give us a population density of about 65 people per square mile. Okay, so the question we were attempting to answer during this lesson is, how do we find the perimeter and area of polygons in the coordinate plane? Well, to find the perimeter, you use the distance formula to find the length of each side, and then you add the side lengths together to get your perimeter. To find the area, you divide your polygon into rectangles and triangles, and then you add the areas of the rectangles and triangles together to get your area. Now, in your notebook, in order to summarize, write a journal entry in which you draw a polygon on a coordinate plane and then explain the steps for finding the polygon's perimeter and area.